let's see. Real quick, make sure everybody's doing okay with these. This one, you don't have to do any special method, right? I mean, who needs what?
7 needs 2.
Yeah, it's 2. So you get 10 and 3. Yeah. So the bottoms are like really easy to see. You don't have to do anything special or anything. The method I kind of show you is when the bottoms are not that obvious. And I even, on that sheet, I broke it down further, because sometimes people have trouble with the real first step, which is what's the biggest number that goes in both. If you have trouble with that, just break them all the way down. But here, I mean, what number goes into both of these? 9. So this is 9 times 5, and this is 9 times 2. If I took 9 to 3 times 3, they both have 2 3s. They both have 2 9s. So if you can see the biggest thing they have in common, break them down according to that. Because then you just focus on what they don't have in common. So what's the first dude need? 2. He needs 5. You guys with me? Sometimes the reaction is, that can't be right, Jeff, it's too easy. Sometimes the reaction is the other way. It's like, I don't understand what the hell you're doing. So I don't know where you guys are with this, but it really is kind of, seems like it can't be right, because it's, what the hell, it's too easy. Just give them what they're missing. What do I get here? I get 4 plus 35, and what's the bottom become? Yeah, 90. 45 times 2, 90. So then I get 39 90ths. You better not stop there. Yeah. What goes into both? 3. So if I divide top and bottom by 3, I get 13 30ths. Kick ass. I'll take that as a positive thing. Yeah, so what about these? Can you guys see the biggest number that goes into both? More than that. Yeah, all right, you're saying 2. You're saying 3. Those are both true, so what's the biggest number that goes in both then? 2 times 3, 6. Ooh, shit.
I mean, could I still possibly have that?
It would still be the right answer. You would have just multiplied by too much.
Right.
So if you can break it up by biggest thing you have in common times whatever else, then you're going to give them the smallest amount they both need. Does that make sense? Instead of getting your kids these giant bowls of ice cream and make them both happy.
And then you gotta reduce the function. Like, I built...
Oh, yeah. So you'll have to reduce it, and you have extra shit in there, so you have to definitely reduce. So here, this is 6 times 7, and this is 6 times 2. So what's he need? 2. And what's he need? 7. I say he, but I don't know. I'm not sure I did check that on this. Turn them over, and what you got? So what do you get? You get 22 minus 35 over, 42 twice, 84, I like it. This here? Yeah, so I gave top and bottom of 2, because he added 2 and he doesn't. Top and bottom of 7, because he's got a 7 with it. I like it. Because the idea of LCD is make the bottoms the same. So if you can figure out how they already are the same, you can focus on why they're not the same. And just attack that piece. And then like somebody said, you get negative 13 over 84. There you go, over. All right, 13, I'm going 84. That's it. Now please understand, if you have a different way to do those kind of problems that you like and that works, it's fantastic. What I try to do is to show people this with numbers so you buy into it more over here. I'm going to do the exact same thing over here. So I'll give you a few more minutes to do these. talked about this guy specifically the other day, so be careful with him.